Now, before we advance in any problem video, what is it that we do? Discuss the formula, right? If you have watched the previous videos, you would know. Anyway, coming back to this video, the formulae that may come in handy today are those of the curved surface area and the total surface area of right circular cones. We have just seen that the former is pi RL and the latter is pi r into r plus L. Here, r is of course the radius of the base, sometimes also known as the radius of the cone, and L is the slant height. So, the only prerequisites in each of these cases are the radius and the slant height. And if you know these two, you can very easily find the height of the cone using the Pythagoras theorem. Remember, L squared is equal to R squared plus H squared. Then H, which is the height or sometimes even the depth of the cone, is root over L squared minus R squared. So, now that we have armed ourselves with the required formula, let's attack the questions right away. As always, we'll start with a simple question. Say this one. It states that the curved surface area of a cone is 308 square centimeters and its slant height is 14 centimeters. We just need to find the radius of the base, the height of the cone, and also the total surface area of the cone. Pretty simple a question, isn't it? There's this right circular cone with slant height 14 centimeters and its curved surface area is given as 308 square centimeters. All we need to do is find the other two basic terms, that is the radius and the height, and also the total surface area of the cone. So, how do you think we should go about this one? Our first requirement is to find the radius of the base, and the only two pieces of information available here are the curved surface area and the slant height. But because we just recapitulated the formula for the curved surface area, we know that these two pieces of information are enough. So, pi RL is equal to 308 square centimeters. On substituting the value of L, that's 14 centimeters, and then making R as the subject, we get R is equal to 7 centimeters. So, the radius of the base of this cone is 7 centimeters. Moving on to the next requirement, the height of the cone, say h, would of course be root over L squared minus R squared. So, on substituting the values of L and R here, we get h is equal to root over 14 squared minus 7 squared. Now, you may either find the values of 14 squared and 7 squared individually and then subtract them, or you could just use 14 plus 7 into 14 minus 7. In any case, you would arrive at h is equal to root over 147 centimeters, which is the same as 7 root 3 centimeters or 12.12 centimeters. For the third requirement, we just have to substitute the values of L and R in the formula for the total surface area, that is pi r into r plus L. So now, the total surface area of this cone is equal to 22 by 7 into 7 into 7 plus 14. 7 obviously gets divided and we are left with 22 into 21, which is the same as 462 square centimeters. So, summarizing, the radius of the base of this cone is 7 centimeters, the height is 12.12 centimeters, and the total surface area is 462 square centimeters. All the three requirements are met, so our question is solved successfully. Watch this video once again for better understanding of the concept and then start solving the problems. I'll be waiting for you in the next video. So, finish up fast and catch me there. Till then, keep ideating and keep exploring.